Would there ever be a time in which you'd want the greatest force possible for a given change in momentum and a given impulse? That'll be the last case we talk about, case 3, when you're decreasing momentum over a very short time interval. In this case, again, the change in momentum is fixed, but this time, instead of minimizing the force, we want to maximize it. We want to make it as big as possible. How do you do that? Minimize the time of the interaction. Now, again, the question is, why?
Why indeed? Well, when you decrease an object's momentum over a very short period of time, the forces involved are huge. Normally, we don't want that to be a case. You don't want that to be the case if you're about to crash in your car, but if you're a karate expert, you do. What a karate expert does, she brings her hand down on a stack of bricks with a whole lot of momentum, and by decreasing the time her hand is in contact with the bricks, she can actually maximize the force on the bricks. Now, don't try the following demonstration at home.
Let's say that I want to crack open a coconut. How do you manage that? Well, I could bring my hand down on it, karate chop style, right? How would I get the largest amount of force out of that motion? It's going to be the same change in momentum regardless. My hand is going to go from a positive speed down to 0. The mass of my hand doesn't change, so same change in momentum. It equals force times time. So if I want to maximize the amount of force on the coconut, I actually want to minimize the amount of time my hand is in contact with the coconut.
Now let's see that in action, karate master brother Matt.
Much to my surprise, that actually did really crack the coconut. Study physics, and one day you'll be a karate master.